Hi everyone, welcome to Chapter 1, Part 1. This is Geography. This may be your first and possibly only geography class that you're taking while in college. So this whole chapter is kind of introducing a lot of the concepts that we're going to talk about all semester and letting you know what geography is in the first place. So what is geography? Geography technically means writing of the earth, but basically it's studying kind of the earth and the way we interact with it. We want to know as geographers where things happen. There's two kind of major divides in physical geography, or sides of geography, excuse me. There's physical geography, which you may be taking this semester with me as well, which is kind of looking at things like temperature and atmosphere and landforms. And then there's human geography, but that's what we're going to be talking about in this class. But we want to know where things happen. We want to know why do they happen there. So here is a population map on the lower half, which is looking at population density globally. And we can see that lots and lots of people, very densely populated in South and East Asia. So we look in geography at physical things and human cultural things. If you take a world regional geography class, you're going to look at both of these things. In this class, we're going to be focusing on the human cultural aspects. But these are both interrelated, right? Where we live, what our population is, how big it is, what food we can grow, those affect us, our kind of human cultural side, but they are part of the physical environment as well. So there's a couple of questions that we're going to want to answer in this lecture. And the first one, why is geography a science, right? This is technically a science class, but we want to know, how does geography help us understand the world? And so we do that by looking at several different concepts. The first being space and place, which I'll talk more in detail about. But space is kind of the spatial patterns across areas on the Earth's surface. So we want to know, why are things happening in certain places? And I'll show you a racial map coming up. But why are more people living in one place and less people living in another? We do this in a couple of ways. We look at regions. In regional geography, we spend our whole time looking at regions, but those are a space with something in common. Europe is a region. We have a lot of countries there that have a lot of things in common. And then scale, how much space are we looking at? Are we looking at something kind of very zoomed in, or are we looking at something on a global level, right? We go from the local to the global, and I'll talk about these a little bit more in depth. Place is a unique point on an Earth's surface, right? So we can think about San Diego as a unique place on the Earth's surface. And then we're also going to be looking at connections between spaces and places. So connections between that distribution of patterns across our planet and then these unique places. So when we think about space, here is that racial dot map that I talked about a second ago, but this is a dot distribution map of race and population across the United States. So imagine that every person gets one dot, and again, the dots are super, super tiny. So the white areas, it doesn't mean nobody lives there, but there's just not enough people necessarily living in those places to show up when we're zoomed out at the United States. You can Google racial dot map or go to the link below and kind of zoom in on your area and look at it. But geographers, again, we want to know, how does one or more variables differ across space, right? Green is African American. Why are there more African Americans living in parts of the South? Why are there more Asians living in Southern California? So again, we're looking at patterns of distribution, and we're going to look at that a lot this semester. These are quantitative measurements generally when we're talking about space. We're talking about numbers. We're counting. We're looking at how many, how dense is something. And we can map these things to show us patterns. A lot of people think about maps, and I'll talk about the different types of maps in a second, but we use maps to show us patterns, not just to show us where locations are. We can map just about any type of information, and that is a great tool for geographers to use that let us show us patterns of distribution through space. And so maps, right? We use maps for reference, and what that means is here's a map of the 50 United, not the 50 United States, but the 48 contiguous United States, right? I want to know where Texas is in relation to New Mexico. I can see that here. And we also use maps for communicating specific data. These are thematic maps as opposed to reference maps. And so here is a map about changing views of the United States throughout Europe. We can see some countries in Europe where the views of positive views of the United States have actually been decreasing, and some places where less places, unfortunately, where positive views of the United States have been increasing. This can literally be anything. You can map anything on a thematic map. Here's a thematic map of which states have more dogs versus more cats, right? Green states have more cats than more dogs. Purple states have more dogs than more cats. But you can map just about any type of data. And we want to think about maps critically. Here is a map that is the percentage of population that is Native American. And so if we look at this map kind of superficially, we're going to say, okay, so it's percentage of the population. Wow, it looks like Native Americans are really just concentrated in a few areas. And if we look at Southern California, we'll say, well, less than 1% is Native American. There are actually lots of Native Americans living in Southern California. It's just that there's a lot of people in general living in Southern California. So they make up a smaller percentage compared to the whole, but there might be more Native Americans living there than in some places that are dark purple just by nature of how many people are living there or how dense the population is. We are also looking at density. With maps, we want to know how many people are living in a specific place for that area, right? How much per area. And then also the concentration, which is how much impact relative to other areas that area is happening. And so, for example, here is Santa Ana. It is high density, but it is not very concentrated, which means it is equally dense all the way across this, this block, right? It's pretty high density, but it's not like that density is concentrated in one area of that block, so it's not concentrated. If we look at Newport Beach, this is low density, but it's also not concentrated, right? It's pretty spread apart across that entire area. As opposed to when we look at Laguna Beach, it is low density, not a lot of people in that area, but it is highly concentrated, right? All of those people are living in one very small strip of land in this satellite image. So again, density is how much per area, how many people are per area usually that we're talking about, and concentration is how much impact it's having relative to other areas surrounding it. We also want to think about map scale. So basically, maps are smaller representations of reality. You couldn't have a map of the state of Florida that was the size of the state of Florida. That would not help us very much. And so again, we want to think critically about what the scale is that we are looking at. So here is a map of Europe that then has a zoomed in larger scale map of Luxembourg. Right? If you were to just look at the map of Luxembourg alone, it would look like Luxembourg is pretty big. Especially there's really no reference here about how big Germany and Belgium and France are. But when we look at it on a smaller scale map, we can see that actually Luxembourg is pretty darn small compared to the rest of Europe. Different scales have different uses. If I'm driving across the United States and I want to map my route, I'm going to have to be able to see the entire United States to look at where the freeways are going. If I want to walk around downtown San Diego, I'm going to want a very different map. Map projections either distort size or shape or both. And what I mean by that is our Earth is a sphere, right? And so we are taking something that is a sphere and trying to represent it in a flat space. So we are trying to take something that is three-dimensional and put it down in a two-dimensional space. And to do that, you can imagine if you had to unwrap the Earth and lay it flat, you're going to have to stretch and pull and distort some places. So basically, map projections are just ways of portraying a 3D Earth as two-dimensional. And so here is a map that a lot of people are probably familiar with. This is a Mercator projection map. Mercator projection really distorts size. It stretches everything out at the poles. Greenland, which is right here, is significantly smaller than Africa. Greenland is about 1/17 the size of Africa, but here it looks very stretched out and very big. It makes Canada look very big. It makes Antarctica look very big. It stretches things out along the poles. Now here is an equivalent map, which does a lot better with size. Here is Greenland again. Here is Africa. This is an Eckert projection, but it has to distort the shape in order to do that. All maps either distort size or shape or both. And we want to remember that. So again, when we look at a map, we want to think critically about that map. This map, the Mercator projection, was really good for seafaring when it was created several hundred years ago. All the lines of longitude and latitude go straight across, but it also disproportionately makes Europe look much bigger than the rest of the world. If you look here, you can get a more honest view of how big Africa is compared to Europe or Greenland. We also want to know what longitude and latitude are. You should know this. We're not going to spend a ton of time talking about it, but it is a good reference point for where things are on the planet. So latitude, which is like a ladder, is how far north or south something is from the equator. So here is the equator on this image from the satellite image. Again, here's that Greenland. Here's Africa. You can really see, wow, huge size discrepancy here. They're not even close to being the same size. But latitude goes from 0 to 90, either north or south. So here is north 10 degrees. So it's how far north or south something is from the equator in degrees. Closer to the equator is warmer, which is one of the main reasons that we care about it, right? Because it has a huge effect on climate. If you were taking my physical geography class or any other physical geography class, you'll learn about why when you get closer to the equator, you get warmer. Longitude is how far east or west something is from the prime meridian, which is here. The prime meridian is kind of arbitrarily placed upon the planet. England got it because England was a huge colonizer and they kind of won where the prime meridian was going to be. But it is kind of loosely the basis for time zones, but it doesn't really tell you anything fundamental about anything. If you are looking at latitude and something is 2 degrees north of the equator in Africa and 2 degrees north of the equator on the other side of the world, they're going to have pretty similar weather in the fact that they're both going to be warm. You could have something 30 degrees east and 30 degrees west, and that doesn't mean anything for its fundamental telling you about place. But longitude and latitude give us a grid that kind of allows us to find where we are on the planet. And then we also want to think when we're talking about maps is when we look at a map like this is land use and land cover for the state of Tennessee. We look at this, we can see where's deciduous forest, where is it urban and developed. You can see kind of those spokes almost coming out from different cities. And we want to think about how we make maps like this. Somebody is not going out and surveying and walking across the entire state of Tennessee to figure all of this out. We're getting a lot of this from satellite imagery and mapping technology. Things such as remote sensing, which is basically using satellite imagery to look at the planet. Often we use infrared in order to do that. We use GPS or global positioning systems in order to figure out exactly where those images are on the planet. And we use GIS, which I'll talk about in a second, which is geographic information systems in order to create the maps. So here is a map created with Geographic Information Systems, or GIS. You can take an ArcGIS. Unfortunately, Miramar does not have it, but Mesa does. And I highly recommend taking a GIS class. Learning to make maps is useful in a lot of professions, not just if you're going to become a geographer. But this is a map looking at schools with students that are high risk for obesity. I'm going to pause here. You're going to do your kind of course introduction, and then you're going to move on to part 2 of the Chapter 1 lecture.